Good morning, it's Dave Kenworthy, the 9th of the 12th, 2021. And today we're going to look at the Howard Crowhurst Septuple Square at Stonehenge. And it's very easy to find this Septuple Square because of the length of the greater cursus, which is 1 3/4 miles. And that's 9,240 feet. And if you look at Stonehenge, it's actually here. And the Septuple Square, there are two of them, from Stonehenge to the cursus, which is here. It's a half a mile, so that's a 1/4 of a mile. And to get to this line that's going at this funny angle across the cursus, it goes from the bottom section there to the top section there. So it's at an angle. Now that is 90 degrees, this line here, which defines the Septuple Square. Because this line here cuts the cursus as 3 here and 4 here. Now that's a mile exactly. And that's 3/4 of a mile. So that's the 1 3/4 miles. So this is setting the 90 degree line, and this is on a back bearing of 176 degrees. So this line that comes across this funny angle down to the bottom right hand corner of the cursus here, that is 90 degrees exactly to this line, which goes up, as we've already explained, it's 17.33 miles long. And it goes to the 3-4-5 triangle within the Aubrey design of Professor Alexander Thom. And the two lines of septuple squares are here. So we've got 9240 along there, 1320 down there, 1320 down there, giving the half mile. And this is the first set of septuple squares here, and this is the second here. And these septuple squares have really extraordinary eclipse mathematics, and that's what we're going to look at. And I think just identifying these at the moment in this video is enough, and in the next video we'll look at the eclipse mathematics. But the most important thing to remember here is that Algernon Berryman tells us that the circle ascribed around a square, the circumference of the circle is in the ratio of 9 to 10 to the perimeter of the inscribed square. So there'll be 7 circles along this line and 7 circles along this line, each one round a square of side 1320 feet, and this is the length of the lesser cursus, 1320 feet. So this is a key to this design, to this whole design. This is the key. And 1320 is a very ancient unit of measure, and it's known as the Saxon foot, which is 13.2 inches, or also the Indus Valley foot, and it's the imperial foot of 12 inches times by 11/10. And it was in use when the Normans invaded England in 1066. And when they finally put together the Doomsday Book, they consolidated the Saxon measure and the Norman measure. And we have now the consolidated imperial system that's been reproduced over time from those traditional old measures that go back all the way to the design of the Aubrey circle here, because this Aubrey circle is designed against 2 units multiplied together. One's 3.3 feet and the other is 2.72 feet, Thom's megalithic yard. Now 3.3 feet is 1.1 times 3. So it's the Saxon foot or the Indus Valley foot times 3. And it gives an ancient metre of 3.3 feet, which is 39.6 inches. Now, each one of those feet is 13.2 inches, and we have in this mile here, there are 4,800 Indus Valley feet or Saxon feet. So this whole septuple double square that I'm analysing is actually based on Old Saxon stroke Indus Valley stroke Babylonian measure. And we know that it has to be because the people who inherited the UK, who moved into the UK, came from the Middle East, and they became the Neolithic farmers. So we've got this line which defines these two septuple squares, and each square is side 1320 feet. So the distance around the square is 5280 feet, which is an English mile. So we're looking here at an area of land that is defining the ancient system of measure. And the cursus is the evidence that we need to show that these people were actually using these measures, with it being 9240 feet long. And when you multiply 1320 by 10 over 9, turning the square to the circle, it becomes 1466.666 recurring, which is the eclipse unit. So there is absolutely no doubt that this whole system of measure that was imported into the UK by the Neolithic farmers is encapsulated in this area around Stonehenge. And as Thom said, the inductees were probably brought here, the brightest inductees were probably brought here to receive their education. They would have been taken up to Brodgar as well. And he says what a striking difference it would be to watch the moon in the sky here at Stonehenge and then go up to Brodgar and see the way that the moon behaves at Brodgar, because it's totally different. And the reason they went as far north as they could was that the further north you go, eventually in Neolithic times, megalithic times, the moon became circumpolar, so it never set. And it could be fully observed, and that's what they wanted to do. And all these measures are related to the tracking of the sun and the moon. And they all fall into place in Thom's analysis of the Aubrey circle at Stonehenge. So that's it for now, and it's something to think about. But when we actually break down these two septuple squares, we can find the mathematics of the eclipse without any doubt. And also the mathematics of the the Egyptian cubit. So that's it for now. Thank you.